1 quarter to go. We're down to 1 quarter. 2 months, basically.
Yeah.
When you think about it, it's 2 months. Okay? You got all of April and all of May. Okay? 2 months. So, what I put over here on the sideboard is, this is your 4th quarter. So you're going to have formatives on those 7 days, which is every Tuesday except this week. So not tomorrow. Okay? But then every Tuesday, the rest of the quarter, you will have a formative. The first 5 will be on the chapter that we're dealing with. The last 2 will be like final type questions to get you thinking about practicing for the final and making you so that you're good to go there. Okay? You will have 4 quizzes in this chapter. Okay, we'll call this chapter 9 because it's really chapter 9 on your textbook. So you'll have 4 quizzes in this chapter. You'll have a chapter test for this chapter. Okay? And your semester final, your 2nd semester final, will be in class on the 22nd and 23rd of May, which is a Wednesday and a Thursday right before you're done. The 24th, is your last day now. The 23rd was originally scheduled to be your last day, but because of the snow day makeups, your last day is now on the 24th. That class is important. That last day of class is important. Don't be like kids a couple of years ago. Okay? A couple of years ago, I had kids that skipped the last day and then tried to get their NTC credit like a month later. It doesn't work that way. If you're going to take that NTC credit and look at how much stuff we've got here, so nobody is locked into their current grade anywhere. Okay? So if you're going to take that NTC credit, you have to be in class on that last day. Because otherwise there's nothing I can do about it. Once I submit my grades to the tech, that's it. Okay? You've got to go through them, and they're not as nice and personable as I am. Okay? They'll laugh at you a lot and say, sorry, I can't do anything about it. Okay? Just so you know. Okay? So we got all that stuff there. Okay? Any questions on that, on the timelines? Chapter 9 is involved, I will say that. Okay? And so what I am going to do right now is I am going to hand back your final note sheet. The note sheet that you started first semester that I said you could use then on the 2nd semester final. Okay? I'm going to hand that back right now because it's got one side that is blank. And in this chapter, there are a lot of formulas and a lot of things that you need to know. Because we're going to talk conic sections. And the 4 conic sections are parabolas, circles, ellipses, and hyperbolas. And there's different stuff that goes along with each one of those. Because there's so much stuff that goes along with each one of those, okay, I am giving you your final note sheets today so that you can start filling them out with certain information from chapter 9. Okay? Now, I would not fill up your entire back blank side of your note sheet with chapter 9 stuff because you've also got systems of equations things, you've got sequences and series things, and all that stuff. I am not giving you anything on the test, on the final. Okay? You have this sheet for your final. Okay? Alright? So, I will periodically throughout this chapter say that is something that should go on your note sheet. Okay? Today I will say it twice. Okay? Alright? So, when I say that, make sure you pull this out or make a note in your notes that says, then transfer it onto here. Okay? Alright, so we're going to start today then with, we're actually going to start nice and slow. we're going to start with applying the distance formula and the midpoint formula, because those are two concepts that you definitely need in this chapter, or in this last chapter of, for the majority of us in the room, the last chapter of your high school careers. Okay? Two hugely important concepts that you've already seen. So we're going to go through them kind of quickly. I'm going to tweak some of the problems a little bit, show you some different ways of doing some stuff. Okay? So the first one is that we are going to find the distance between 2 points. Okay? Now, these 2 points could be located anywhere in the in space. Okay? In the two-dimensional space, I should say. Okay? So these points are anywhere in there. And the distance between those 2 points is the formula d equals the square root of the x parts subtracted and then squared plus the y parts subtracted and squared of the 2 points. There is one kicker in the distance formula, and that is for the y parts. It doesn't matter which point you start with for the x's. Okay? If I scroll back up here, if I start on the left, that's fine. If you start on the right, that's fine. That part doesn't matter. But what matters is then that the y parts are in the same order as your x parts. So if you started on the left, then your y's also have to start on the left. If you started on the right, then your y's have to start on the right. Or with the right point, I should say. Okay? The nice part about the distance formula is that our answers are always in simplified radical form. Okay? So really, we don't need a calculator when we're doing the distance formula, because we can do it all mentally. Okay? Because the numbers will normally be within that range of things that we know how to square. Okay? Let's try one. Huh? So I want to find the distance between the point -5, 1 and the point -3, 2. Now I'm actually going to do this particular example twice. First, I'm going to use the left point first and the right point second. And then my second time through, I'm going to use the right point first and the left point second. In the end, we should get the same answer because the points didn't change. The distance left to right should be the same as the distance right to left. Okay? So, first off, refresher, distance is equal to the x parts subtracted and squared, and the y parts subtracted and squared, and then I take the square root of that whole thing. So this is going to be -5 minus 3, then I square that. 1 minus 2, then I square that. Okay? Now, most of this math you can mentally do in your head. I would like it if you showed me a couple of steps along the way. So one step that I could show, -5 minus -3 is really like -5 plus 3, which is -2, and then I've got to square that. 1 minus 2 is -1, and I've got to square that, and that is all still under my radical. -2 squared is -2 times -2, which is what? What is -2 times -2? 4. Okay. -1 times -1, or -1 squared, if you will, 1. 4 plus 1, 5. So I get here that the distance between those 2 points from left to right is the square root of 5. And I would leave it as that. I wouldn't go further with a calculator and say that it's 2.236061777. Okay? I knew the 2.236 part that I made up was 0.6177. How close was I? Pretty close. There it is. 2.236066797. Okay. Now let's do it the other way. So now I'm going to start with the right point first. So that's going to be -3 minus -5. And then 2 minus 1. Again, I have to square root all of that. -3 minus -5 is positive 2. 2 minus 1 is positive 1. Still have to square both of those. 4 plus 1. Again, I get the square root of 5. Okay? So the distance between those 2 points is the square root of 5. Again, the only reason I did it twice to show you that it doesn't matter which point you choose first. Okay? Second concept that I need, side note I forgot to say, distance formula, that would be one thing that I would definitely put down on my note sheet. Okay? Because that will come up throughout the whole chapter so far. Okay? Midpoint, again, second thing I would definitely put down on my note sheet. Okay? Midpoint is just that. It is the point in the middle of 2 other points. It creates 2 equidistant segments from the endpoints of a segment. Okay? It can also be referred to as the bisector. Okay? So a midpoint is also a bisector. It's cutting the segment into 2 equal parts. Okay? To find the midpoint, we average the x's and we average the y's. So I take the x parts, I add them together, and I divide by 2. I take the y parts and I average them together, and I divide by 2. Okay? Now the difference here is that the midpoint is a point, so in the end, I am going to write it as an ordered pair. X, comma, y. Distance is a length. It's a number. It's a single solitary number. Midpoint is a point, so it's got 2 parts to it. So when I say find the midpoint of the segment joining -2, 3 and 4, -2, what we're doing there is, again, I would start with my midpoint formula. Midpoint x's divided by 2, y's divided by 2. So then this would be -2 plus 4 divided by 2, and 3 plus -2 divided by 2. -2 plus 4 is +2. +2 divided by 2 is +1. 3 plus -2 is +1. +1 divided by 2 is 1/2. So my answer here, the midpoint between those points, is 1, 1/2. Fractions preferred on that one, so you don't get confused with decimal points and commas and make it look nice and neat. Fraction form is the neat form. Okay? Yes? Now, little geometry for you. 3 ways that I can classify a triangle using side lengths is it could be a scalene, an isosceles, or an equilateral triangle. We could also classify a triangle by its angles, right, acute, and obtuse. Okay? But we're going to deal with lengths of sides here. We're not going to deal with angles right now. Okay? So what do those 3 geometric terms mean? What does scalene mean? What does isosceles mean? And what does equilateral mean?
Scalene, none of the sides are the same.
None of the sides are the same is scalene, yes. So a scalene triangle has 3 distinct side lengths. No side lengths are the same. Okay? 2 more to go.
2 of the sides the same.
Which one?
Not the base.
No, but which isosceles or equilateral? Isosceles, so 2 as 2 equal sides?
Yeah.
Yep. So an isosceles has 2 equal sides. Equilateral. What does equilateral mean? What do you got? All of the sides are equal. So in this case, because we're dealing with a triangle, it's got 3 equal sides. It's got 3 equal sides. So if I gave you a problem, something like this, that said, classify the triangle that has vertices at point A, which is at the point 2, 1, point B, which is at the point -3, 3, and point C, which is at the point -2, -2, what would you have to do in order to classify that as either scalene, isosceles, or equilateral? You have to find the 3 side lengths using the distance formula. Yeah. So what I would like you to do now is classify this triangle either as scalene, isosceles, or equilateral. Alright, so I'll do AB in blue. So that's going to be 2 minus -3. And I got to square that. And then 1 minus 3. And I got to square that. Okay? So that gives me 2 minus -3 is 5. 5 squared is 25. 1 minus 3 is negative 2. Squared is positive 4. So I get that the side length for AB is the square root of 29. Do we all agree with side AB is the square root of 29? Okay. Then I'm going to do A and C. Make sure I leave those points there. A and C has, I'll do that one in a different color, so we'll go green there. So I'm going to go 2 minus negative 2 and 1 minus negative 2. 2 minus negative 2 is 4. 4 squared is the greatest kids game ever. Okay, or 16, whichever one you prefer. 1 minus negative 2 is 3. 3 squared is 9. 16 plus 9 is 25. The square root of 25 is 5. Okay. So side AC is 5. Do we agree with that one? Okay. Side BC then, so B first, so that's going to be negative 3 minus negative 2, and then I've got to square that, and 3 minus negative 2, and I've got to square that. All of that then is getting under a square root. Negative 3 minus negative 2 is negative 1. Squared is 1. 3 minus negative 2 is 5. Squared is 25. All under a square root. That leaves me with the square root of 26 there then as that side length. Any of the sides the same? No, none of them are the same. So triangle ABC is classified as scalene. Yes. Or just scalene would work too. Yeah. Because then that's the classification. I don't just want the 3. Unless it was asking for the 3 side lengths. Okay. Good to go on that one? Awesome sauce. Okay. Another style of problem that you might see here throughout this chapter. Write the equation of a perpendicular bisector of the line segment joining A and B. Okay? Well, the first thing that we would have to do is we would have to find the midpoint of line segment AB. And the reason that we have to find that point is we need it for that's where the line that we're trying to find is going to be going through that point. So I'm going to add my x terms, divide by 2. I'm going to add my y terms and divide by 2. And that gives me the midpoint is going to be at 5 plus negative 1 is 4. 4 divided by 2 is 2. 4 plus 6 is 10. Divided by 2 is 5. So the midpoint, this point right there, is the point 2, 5. Agree? Or if we had a graph, we could have graphed it out and it just so happened to be nice and neat for us that it landed right at a point. Okay? The second thing that I am going to do is I am going to find the slope of segment AB. And the reason that I am going to find the slope of segment AB is because I need to be perpendicular to it. So there are two ways that I could go about this. I could find the slope by doing rise over run from A to B or from B to A, it doesn't matter. I rise, if I'm going from A to B, I rise 2. I run 1, 2, 3, 4, 5, and 6, but I'm in the negative direction, so I run negative 6 there, which that fraction can be reduced down to negative 1/3. If you're not a fan of doing rise over run, the other option you have is you can subtract the y's over subtracting the x's if you don't have a graph. So then that would be 4 minus 6 all over 5 minus negative 1, which would be negative 2 over 6, which still gets me negative 1/3 as a slope. Okay? Next, I'm going to find the slope of the perpendicular line. Refreshing my memory, perpendicular slopes are what? Two words, perpendicular slopes. Opposite reciprocals, yeah. Oops. Okay. So perpendicular slopes are opposite reciprocals. The opposite means what? What does the opposite of opposite reciprocals mean?
If it's positive, make it negative. If it's negative, make it positive.
Okay, so I changed the sign. Okay, reciprocal means what?
Flip it.
Flip it. So I have to change the sign and flip it. So if my slope was negative 1/3, then my perpendicular slope is going to be what? Just 3, because I would take 1/3 and I would flip it, and then I would take the negative away. So it would just be positive 3. Okay. Now, probably a good thing that I handed back your note sheets from first semester, okay? Because now we've got a point of 2, 5, that's our midpoint. We've got a slope of positive 3, so that means that we can use the point slope form, y minus y sub 1 equals m times the quantity x minus x sub 1, which is probably on the front side of your note sheet, because that was a first semester concept. Okay? So then this is going to become y minus 5 is going to equal 3 times the quantity x minus 2. And then just simply doing some math, this gets me y minus 5 equals 3x minus 6. So y is going to equal 3x minus 1. As the perpendicular bisector of points A and B. Okay. Good times. Good Good times. Okay. So, another style of problem that you would see in this particular section is the distance between 2 points is the square root of 18. One of the points is at 4, 6. 2, 4, 2, 4, 6. So here is 4, 6. The other one is somewhere along the y equals 3 line. And 3, that's this line right there. So the other one is somewhere on that one. We want to find the coordinates that would make it fit so that the distance between the 2 points is in fact the square root of 18. Okay? Well, distance formula is that I know what the distance is. I know that that distance is the square root of 18. I know that my first x value is 4. My second x value is x. My first y value is 6, and my second y value is 3. So I'm there. Okay? What would you do next with this rainbow of fun? What would you do next?
I think you're missing the squares.
Oh, I'm missing a square, aren't I?
You're missing
right.
2 of them.
No?
The one right above it.
Oh, right up top. There. So I am missing 2. I was looking just at that line. So now what would you do with the rainbow of colors?
Simplify.
How?
Figure out the 6 minus 3 squared is
Okay, so what is 6 minus 3? 3 squared? 9. Okay, so that this part right here is 9. Okay, what else would we do? What do you got?
square 4 minus x.
I wouldn't square that. No. Because that's gonna give me something goofy.
Would you square root 4 and then square root x?
Can't do that. That's bad maths.
Isn't it that 4x and then 4 minus, isn't it like 4 minus x and 4 minus x?
But I would do something even before I do
You
that.
should get rid of
The square roots?
yeah,
How would I do that?
square root
I'd not square root it.
or square.
Square it. And if I'm going to square it, I'm going to square both sides. If I square both sides, now this becomes, and I'll just go back to one color now. I'll just go back to blue here. 18, because the square root of 18 squared is 18, equals 4 minus x quantity squared plus that 9 that we figured out before, because 6 minus 3 is 3. 3 squared is 9. Okay. All right. Now what?
Subtract 9.
Now I would subtract 9. Okay. So then that's going to give me 9 is equal to 4 minus x quantity squared. Square root both sides. Can we do that? Yep, we can do that. On the right side, what do I get? Right side I get 4 minus x. Left side, what do I get? No. Plus or minus 3. Again, that whole even root solving thing comes back to haunt us, right? Okay. So I get 4 minus x equals plus or minus 3. So then, now what? Can I add x to both sides? I can do that, right? So then that would give me x plus or minus 3 equals 4, right? Can I go x equals 4 minus or plus 3? Because if I was adding it, I would subtract it. If I was subtracting it, I'd add it, right? So what is 4 plus 3? 4 plus 3? 7. What is 4 minus 3? 1. Now, logically thinking, if I go back up here to my original drawing, okay, so if I put in a line segment right there, okay, if I do that, okay, it meets up at this point. Yes, totally get it. And this line segment is the square root of 18 long. But then, if I am able to, this one, come on, there it is. If I am able to swing that line segment over to there, now this is also the square root of 18 long. So I need to have two answers because I've locked in that distance. Okay?
So would you just draw like 2 lines right down and have to figure that out?
Okay. Which, and that plus or minus gets me both of them. If I forget that, I only get the one. I don't get them both. Okay? All right. This homework will be due on Wednesday. There is no formative this week. So no formative tomorrow. Unless you guys want me to make one. I can easily make one up for you. But it would just be on, it'd be on distance midpoint, so it'd be pretty easy stuff.